Hello everyone, myself Usha Mirajkar, Selection Grade Lecturer, Electronics and Communication Department, Government Polytechnic, Belgaum. Today we are going to study the subject Advanced Communication, that is for 5th semester Diploma Electronics and Communication Engineering students. In this particular subject, the unit is Unit 2 Radar Principles and Applications. In this particular, the session 1. Here we are going to study about the radar principles and systems. The topics which we are going to cover: basic function of the radar, basic principle, types of radar, applications, basic block diagram of radar, frequency and power range used, and the pulse characteristics. Radar principles. What is radar? That is, radar means it is radio detection and ranging. Radio detection and ranging. Here it is RADAR. This is forming the word radar. RADAR. Therefore, radar is nothing but the radio detection and ranging. The basic functions of the radar are target detection, identification of target location, determining the target velocity. Target detection means here the radar is used to find out the target, whether the target is there or not. The detecting the target, that is also one of the major tasks of the radar here. After detecting a target, once the target is captured, to identify its exact location, exactly at what distance it is there from the station or the radar station, that is the identification of the target location here. Next, if the target is moving or stationary, to identify the target's status here, whether it is the moving target or the stationary target, and if it is moving, then to determine the target velocity here. That is also done by the radar here. These are the major functions which are carried by the radar. Now, if you observe the basic principles of the radar here, here we will be having the radar station, and this is the target section here. In the radar station, we are having the transmitter section, receiver section, and the antenna arrangement here. Now, radar here, the basic principle is the radio waves or the RF signals are radiated in the space. Very high frequency RF signals are radiated in the space and they are traveling. Once any target comes in between, the waves will strike the target here. Those radiated waves will strike the target and they will reflect back towards the radar station here. Now those reflected signals are called as the echo signals. Those reflected signals are called as the echo signals, and those signals are received at the station and those are processed to find the information about the target, that is the presence of the target, the distance of the target or the location of the target, and also to find the velocity of the target and also identify moving or the stationary target here. Now here if you observe here, these red color waves, those are moving here. Those are the emitted wave or the transmitted signals here. Red color waves are the transmitted signals, and here green color waves represents the reflected wave or the echo signals here. Now this is the distance from the radar station to the target. That is distance from the radar station to the target. And if the radiated power, the transmitting power is increased, the distance will increase here. We can capture the larger area. If the radiated power will be less, small amount of energy is radiated means the capture area is small here. Therefore, the distance depends on the transmitted power here, peak transmitted power. This is the arrangement here. Next, depending on the working gear, the types of the radar. Basically, we are having the primary radar, secondary radar, pulsed radar and the continuous wave radar here. Primary radar means that is the radar station is emitting the signals or transmitting the radiations, and those radiation will hit the target and they will come back or reflect back, and those reflected signals or the echo signals are collected, and those echo signals are collected and processed, and that is called as the primary radar. Secondary radar means in this case again the signals are radiated from the transmitter here or the radar station, and those are targeted towards the target position, and those signals are received there at the target, and those are received, those are analyzed, again the one more signal is radiated towards the radar station, and that signal is collected, and that is called as the secondary radar. Pulsed radar, if the information radiated or the signals which radar station is radiating, if that is in the form of pulses, then it is called as the pulsed radar. If the signal radiated is in the form of the continuous wave, then that is called as the continuous wave radar here. Now applications of the radar. In which area the radars are used here? First one is the aircraft navigation. Second is the ship safety. Next is the space, remote sensing, law enforcement, and the military application. These are the major applications of the radar here. Aircraft and navigation, that is in the air surveillance radar is used to detect and display the aircraft's position in the airport terminal. Basically it is like the air traffic controller here. It is like the air traffic controller, such that these radars are used to locate the aircrafts and guide them to take the safest path here. Next is to guide the aircraft to land in the bad weather using the precision approach radar. That is, in case of the bad weather condition, the pilots are unable to give the decision here, that is where to land. In that case, the radars are used to guide them, to locate them, and to show the correct path for the landing here. That is the one of the major application of the radar here. That is for navigation of the landing system of the aircrafts. Next is to scan the airport surface for the aircraft and the ground vehicle positions here. To scan the airport surface such that where is the location for the landing here. For that purpose also the radars are used here. Second application is the ship safety here. Radar is used for enhancing the safety of ship travel by the warning of collision with other ships here. Means the main application, this also same as the ship navigation here. It is showing the path to the ships such that they will travel in the safest path here by giving some warnings of with the collision of the other ships or the icebergs, showing the path here such that they can travel in the safest path here. Next is the navigating the ships under the conditions of the poor visibility. Again, in case of the poor visibility, to show the path, correct path for the ships here. In the space application here, to guide the space vehicles for the safe landing on moon here. That is the major application. Next is to observe the planetary system, the radars are used, and also to detect and track the satellites here. The remote sensing application. Radar are used for the sensing the weather here. Means here in case of the weather forecasting. For the weather forecasting application, radar signals are used to find out the weather forecasting here. Next, it is also used to detect the earth resources like water resource, agriculture resource, forestry conditions, etc. To find those also the radar signals are used here. Next is the law enforcement application. In the law enforcement application, radars are used for the measurement of the speed of the automobile by the traffic highway police here. That is, in case of the city level or the city region, the speed should be limited there within the safest speed. For that, to measure whether the vehicles are moving at the safest speed or with the city level speed, the traffic police or the highway police, they will use this radar system to find out the speed of the vehicles here. Military application. Again, in the military application, in air defense, it is used for the target detection and the target recognition and the weapon control. As we have discussed, that is the secondary radar. The main application, the secondary radar in the military, that is to find the friend or foe here, identification of friend or foe. That is, in case of the secondary radar, the signals are radiated towards the target. For example, aircraft. Again, if it is our aircraft, means it is having the transmitter and receiver section, it will receive the coded signal there. Again, it will decode at the receiving end. Again, it will transmit the correct information towards the radar station. If the radar station is receiving correct information, that indicates that is our aircraft and that is the friend here. If the, for example, the enemy's aircraft is present, if the radar station is radiating the coded information towards that enemy's aircraft, even though they are receiving the signal, but they are unable to decode it because decoding information is unavailable there. Therefore, they are unable to send the correct signal towards the radar station. Now, that is identified as the foe here, that is the enemy's aircraft. Therefore, that secondary radar is playing very important role in the military application here. Next is again in the missile system to guide the weapons here. Identify the enemy locations in the map. For that also radars are used. Now we will watch one small video showing the applications of the radar here.
List out some applications of radar. Air and sea navigation is made entirely safe with radar installations. High-flying planes and ships at sea can get detailed reports of mountains, icebergs, rivers, lakes, shorelines, etc., which they can avoid. Radar systems are used for safe landing of aircrafts. On approaching the airfield, the pilot is guided by signals from the radar set so that it flies along the line of the runway and lands safely, whatever be the visibility. Raindrops may reflect suitable radar signals and thus enable the meteorologist to measure the distance of the clouds with great accuracy for forecasting. The pulses can be used for discovering the position of buried metals, oils, and ores.
Okay, now let us see the simplified block diagram of the radar. If you observe the radar, from the principle of the radar should transmit the signals, RF signals towards the target. Here, if you observe here, and it should be able to receive the echo signal here. Means it should transmit the signal and it should receive the signal. To transmit and receive means what? It should have one transmitter section and one receiver section here. This transmitter section will radiate the energy towards the target and receiver will receive the echo signals and it will process the signals here. Now here it is, if you can observe here, the transmitter and receiver both are connected to the same antenna arrangement here. Means same antenna we are using for both the transmission and the receiving purpose here. Now the circuit which is protecting the sensitive receiver from the transmitted signal is the duplexer. The main job of the duplexer is to disconnect the receiving section whenever the transmitter is transmitting the signal, and when the receiver is receiving the echo signals, it will temporarily disconnect the transmitter from the section here. Means it will protect the receiver from the high voltages of the transmitter here. It will switches from receiver to transmitter, transmitter to receiver here. Therefore, it is a protective circuit such that it will takes care that whenever the transmission process is going on, receiver is disconnected here. Therefore, the system which are using the same antenna for the both the transmission and the reception is called as the monostatic radars. And also, if we are using the different antenna sets here, for example, it is also having on different antenna set and it is also having different antenna set, then also it works. In that case, the transmitter antenna gain should be high compared to the receiving antenna, because it should transmit the higher energies here, but it is receiving the low energy because echo signals are of very less strength here. Therefore, the gain should be high here compared to the receiving antenna. Now, these are the chart showing frequency and wavelength used in the radar. This is the band of the frequency, that is the names of the band. VHF band, UHF, L, S, C, X, KU, KA, V, W. And these are the frequency ranges here. The frequency ranges which we are allotted for these particular bands. And these are the wavelengths here. Now, in case of the radar, to identify the target here, to locate the target or to identify the target, the wavelength should be very small compared to the size of the target. Compared to the size of the target, the wavelength should be small. Therefore, if wavelength is small, means the frequency is high, because both are inversely proportional here. Therefore, in case of the radar, the frequencies, the signals which are used here, the very high frequency signals here. Now, the pulse characteristics. As we discussed, there are two types of radars. One is the continuous wave radar and one is the pulsed radar here. In case of the pulse radar, the signals are transmitted in the form of pulses there. Therefore, the transmitter should be switched on and off, on and off here. First it is on, again off, on, off. Like this, it should be switched on and off there. Therefore, the circuit which is doing this job, it is called as the modulator here. Modulator is switching on and off the transmitter section. Now, just we'll go through some of the parameters of this pulse waveform here. If you observe the waveform, this is the 0 level and this is the high level here. High level, and this is the pulse amplitude. And this is it is going from the 0 to high level. It is called as the leading edge. And what is it is coming from the high level to low level, it is called as the trailing edge here. Now, this on period and this is the off period. Where the pulse is present, that is called as the on period, and when the pulse is absent, that is called as the off period. And this is called as the pulse width and this is called as the phase width. And combination of these two, it is the time period of the signal here. Now, let us see some of the parameters of this pulse waveform here. Now, see here, this is the pulse characteristics. The first parameter is the pulse repetition time, that is the PRT. The pulse repetition time, it states that it is the time measured from the leading edge of one pulse to the leading edge of the next pulse. That is called as the pulse repetition time here. Next is the pulse repetition frequency. It is nothing but the reciprocal of the pulse repetition time here. Reciprocal of the pulse repetition time, that is 1 upon PRT. That is called as the pulse repetition frequency here. Next is the pulse width. It is the time which is measured, T on. The T on where the pulse is present, that is called as the pulse width and it is denoted by PW. Next is the space width here. Space width is nothing but the T off time here, where the pulse is absent. That T off is called as the space width here. Next is the duty cycle here. Duty cycle is defined as it is the ratio of the pulse width to the time period. That is T on divided by PRT. That is T on divided by T on plus T off into 100 expressed in the percentage. Next is the peak power. Peak power is defined as the power which will be generated if the transmitter operates continuously. Typical value of the peak power lies in the range of 100 to 800 kilowatt. Next is the average power. The average power is defined as it is the product of duty cycle into peak power here. Therefore, that product of duty cycle into peak power, it is called as the average power here. Now, these are the sum of the parameters of the pulse waveform here. Again, that is displayed here, those definitions here. Just you can go through. Okay. Next, let us watch some videos such that we'll get clarification about the concept of the radar.
Radar stands for radio detection and ranging. It works with frequencies in ultra-high range. Our system works on the principle of Doppler effect and echo that occur due to the wave nature of electromagnetic field, and are used to track the motion, speed, and direction of objects. These systems have been employed on navigation, air traffic control, mapping, and meteorology. NASA also used radars to map Venus's surface because Venus is covered with clouds that are impenetrable by visible wavelengths. Radar works by transmitting radio signals at equal intervals of time. The time difference between the transmitted signal and the received signal determines the distance of objects, and the position that the signal is picked determines the bearing. Most radar systems are two-dimensional and display their position in polar coordinates. Thank you for watching. Until next time, keep learning.
Okay, let us watch one more video.
Radar. Radar is a method of detecting distant objects and determining their position, velocity, or other characteristics by analysis of very high-frequency radio waves reflected from their surfaces. The word radar stands for radio detection and ranging. Several inventors, scientists, and engineers contributed to the development of radar. The first to use radio waves to detect the presence of distant metallic objects was Christian Holzmeier. Whether it's mounted on a plane, a ship, or anything else, radar set needs the same basic set of components: something to generate radio waves, something to send them out into space, something to receive them, and some means of displaying information so the radar operator can quickly understand it. The radar waves are generated by a piece of equipment called a magnetron. Radio waves are similar to light. They are made up of fluctuating patterns of electrical and magnetic energy, just like the light waves, and they travel at the same speed. But your waves have much longer wavelengths and higher frequencies. Once the radio waves have been generated, an antenna working as a transmitter hurls them into space. The antenna is usually curved so it focuses the waves into a precise, narrow beam, but radar antennas also typically rotate so that they can detect movements over a large area. The radio waves travel outward from the antenna at the speed of light and keep going until they hit something. Then some of them bounce back towards the antenna in a beam of reflected radio waves, also traveling at the speed of light. Any reflected radio waves picked up by the antenna are directed into a piece of computerized electronic equipment that processes and displays them in a meaningful form on a television-like screen, watched all the time by a human operator. The receiving equipment filters out useless reflection from the ground, buildings, and so on, displaying only significant reflections on the screen itself. Using radar, an operator can see any nearby ships or planes, where they are, how quickly they are traveling, and where they are heading. There's one more important piece of equipment in the radar apparatus. It's called a duplexer, and it makes the antenna swap back and forth between being a transmitter and a receiver. Radar is something that is in use all around us, although it is normally invisible. Air traffic control uses radar to track planes both on the ground and in the air, and also to guide planes in for smooth landings. Police use radar to detect the speed of passing motorists. NASA uses radar to map the Earth and other planets, to track satellites and space debris, and to help with things like docking and maneuvering. The military uses it to detect the enemy and to guide weapons. Meteorologists use radar to track storms, hurricanes, and tornadoes.
Okay, students. Now we have one small test here. That is the MCQ test. Try to answer these things. It will be very interesting.
Multiple choice questions based on the introduction, the contraction of a word which forms the radar. So radar stands for radio detection and ranging. So B must be the correct answer. Question number 2 is the gain of radar transmitting antenna is. 4 options have been given. Less than that of receiving antenna, almost equal to the receiving antenna, means here gain of transmitting and receiving antennas have been compared, and what is the relationship? So you must know that the gain of transmitting antenna must always be higher than the receiving antenna, because what is our requirement? To transmit as much as the signal required. So it must be high. D is the correct answer. Question number 3 is the radar in which both transmission and reception is done using the same antenna. So that type of radar where it is being done with the use of single antenna is known as monostatic radar. So A is the correct answer. Question number 4 is when a power PT is transmitted by an antenna, then amount of energy which is incident on the target is given by, you know that the flux density you can write at a distance r, which is PT upon 4 pi r square. And when this particular power PT is transmitted by the antenna, then gain of that particular antenna must also be considered. So A is the correct answer. Question number 5 is radar range primarily depends upon. What is the factor upon which radar range depends? So it depends on the transmitted power. What is the peak transmitted power? So out of these 4 options, A is the correct one. Question number 6 is in radar transmitter, the function of modulator is. Options have been given: allow the use of same antenna, switch the tube off and on, control pulse repetition frequency, and increase maximum range. So the function of modulator which is used in the transmitter side, its function is to switch the tube on and off whenever required. So B is the correct answer. Question number 7 is the average power of a pulsed radar transmitter. Average power, you know, it is being denoted by a term P average. So how it is being given? Certain options have been given: product of peak power of the pulse and the duty cycle, peak power divided by number of this. If you remember the formula of duty cycle, so what is this duty cycle? Duty cycle is actually the ratio of average power to the peak power. It means P average is what? This is the product of these two terms. So A is the correct answer. Question number 8 is high pulse repetition frequency, high PRF in radar will do what? It will increase the range of radar, or it will make the weak signal discernible, or improve the signal to noise ratio, or all of the above. So in case if the PRF is kept very high, it will improve the signal to noise ratio. So C must be the correct answer. Let us check. Yes, it is. Question number 9 is minimum range of detection by a pulse radar depends on. Pulse radar does what? It transmits the signal in the form of the pulses. So pulse radar, its minimum range of detection depends upon the pulse width. A. This is the correct answer. Yes, pulse width is the correct answer. Next question is, a duplexer is, you know that the duplexer is a component whenever there is a use of single antenna via which transmission and reception takes place. Then this duplexer does what? It actually works as a transmit receive switch. So in question number 10, B is the correct answer, which is the transmit receive switch.
Okay, this completes the first session. Thank you, one and all.